Welcome everyone to the live interactive session number 11 of the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today we are going to discuss some sample problems which will be useful for solving assignment number 11. My name is Anina Mandal. I am TA for this course. So as sir has already discussed in the lectures that uh, about in-plane and out-plane stresses in a laminate. So in-plane stresses we already talk about and know about, but from how in-plane stresses are related to out-plane stresses that are already defined, and for that we need the stress equilibrium equations. And from the stress equilibrium equations, when we define it, we can get the out of plane stresses such as tau xz, tau yz, and tau and sigma z with the help of the in-plane stresses like tau xy and sigma y. And these out of plane stresses are the ones which are responsible for any delamination. Now, first question is that in a plus 45 degree and minus 45 degree symmetric graphite epoxy laminate, which of the following options are correct? So, options are whether the mu xy for the 45 degree plus is equal to minus 45 degree, it is not equal to each other. It is mu xy 45 plus degree is equal to 2 times of mu xy minus 45 degree, or mu xy plus 45 degree is equal to 2 mu xy minus 45 degree and equal to 0. So answer for this will be option A, that as Poisson mu is Poisson ratio. So Poisson ratio depends on the transverse and the longitudinal stresses. So when the angle will decrease, they even though their positioning of the fibers will be opposite, but the values of the transverse by longitudinal load will be the same. That's why the value for both plus and minus, the mu value will be equal. The next question is that in a plus 45 degree, minus 45 degree symmetric graphite epoxy laminate, which of the options are correct? The options are A, eta xy x plus 45 degree equal to eta xy x minus 45 degree. Eta xy x plus 45 degree is not equal to that of minus 45 degree, or these two are same and equal to 0, or eta xy x plus 45 degree is equal to 2 times of eta xy x minus 45 degree. So here, due to the existence of shear extension coupling in the positive theta and negative theta layers, the difference in shear extension coupling is responsible for tau xz. Is that both of these values will be equal, but one of the value will be negative of the other. So for this option, the eta values for 45 degree plus 45 degree will be equal and negative of that of eta value of minus 45 degree. So the options here are either they are equal or they are equal to 0, non-equal, or equal to 2 times. So as it is negative of it, it is not equal. That's why option B will be the correct one, that the value for plus and minus 45 degree is not equal, and one of the value is negative of the other one. The next question is in a 090.
Ma'am, ma'am, but for the Poisson's ratio are same, ma'am, before in before questions.
Can you ask your doubts at the end, because in the middle, then my flow gets stopped.
Okay, ma'am.
I will answer your doubts at the end. I will. Okay, so in a 090 symmetric graphite epoxy laminate, they're saying what is the condition for Poisson ratio. So either the Poisson ratio is equal, either they are non-equal, one is negative of the other, or they are both equal and is equal to 0. So as you know, Poisson ratio is transverse strength by longitudinal strength. So when the 0 degree, the fibers are aligned is 0 degree, so the longitudinal stress in that direction will be higher and transverse will be low. Whereas for 90 degree, if we are considering the same x and y direction for that laminate, so the for 90 degree, the longitudinal will be the transverse condition of the laminate. Okay, so that means the longitude, the x direction for the 90 degree one will be equal to 90 degree of the alignment of the fibers. So that's why for both this angle 0 degree and 90 degree, the mu value will be not equal, because the longitudinal stress and transverse strength of both of these will be opposite to each other. So that's why the option B is the correct one, that their values are not equal. In a 0 degree, 90 degree symmetric graphite epoxy laminate, so what about the eta value? So for eta value, both for 0 and 90 degree, it will be equal to 0, as both of them don't have any values of stresses because of shear. So if the laminates have some fibers in an angle, then the shear forces takes place. But if they're in 90 and 0 degree, then as you can see, when you will solve for the stiffness matrix and everything, all the components of the shear which are related with the shear are equal to 0. So that's why for 090 the shear stresses are equal to 0. That's why the eta values will also be equal to 0 for 0 and 90 degree. Next is that in a 0 degree, 090 symmetric graphite epoxy laminate when subjected to axial load NX, which of the following interlaminar stresses develop at the free edges? So, uh, interlaminar stresses at the outer plane stresses. So, they are saying if there is an axial load NX, so which of the following stresses will be developed at the free edge? So, NX will be related to sigma y, because it as it is 090 symmetric, so whenever you are putting the value of any load to it, then you will need to get the ABBD matrix, and from the ABBD matrix you and the load, you will get the value of the strain, that is epsilon. So from epsilon values, when you will use the reduced stiffness matrix, then you will get the value of stresses. Now for a 090 symmetric laminate, the values of strain will be equal to, the value of shear strain will be equal to 0. Now, as this shear strain is equal to 0, so finally the shear stress will also be equal to 0. That is tau xy will be equal to 0. So this same question is also taught in the lectures by sir, that what will be the effect of NX when put in a 090 symmetric laminate. So the same thing here, that when you will see in that example also, when NX is added to this laminate, you will get the strain values in x and y direction, but shear strain will be equal to 0. So because shear strain is equal to 0, shear stress will also be equal to 0. So now from that conclusion, you can see this that out of plane stresses at free edges. So for getting tau xz, you will need the value of tau xy. For tau yz, you will need the value of sigma y, and for sigma z, you will need the value of sigma y. So from that you can correlate that if you're loading nx and you're not getting any shear stresses, that means tau xy is equal to 0. So this first condition that says that tau xy is not equal to 0, then we will get tau xz. So, but here in this case, tau xy value will be equal to 0. So, you will not be getting tau xz. Then you will see that sigma y values are known to us. So, in this condition, at the end, you will get the value of stress in y direction. So, if we know the value of sigma y, we can get value of both tau yz and sigma z. So, from this condition, you can conclude that for this given question, which of the interlaminar stresses will be developed. So you get that tau yz and sigma z values we will get. So the option C is the correct one. Similarly, in a plus 45 minus 45 symmetric graphite epoxy laminate when subjected to axial load NX, which of the following interlaminar stresses develop at the free edges? So as sir has also discussed this one in his lectures about plus minus theta symmetric laminate. So in that also, when you will apply NX load for the minus 45 plus minus theta symmetric laminate, so the output you will get is that sigma x plus sigma x minus theta will not equal to 0, but sigma y plus theta, sigma y minus theta values will be equal to 0. So you see, to get the conclusion of interlaminar stresses, the first condition we need to see whether tau xy and sigma y values are known to us. So from putting the load in this kind of laminate, the conclusion you get is that sigma x will be not equal to 0, but sigma y will be equal to 0. And tau xy plus theta will be not equal to 0, tau xy minus theta will be not equal to 0, but this will be positive and negative values. So that means we have the values of sigma x, tau xy of both the laminate, plus and minus theta. Now from that we get the conclusion which out of plane stresses we will get. So tau xy value we know. So we will get tau xz. Sigma y value is equal to 0. So we will not get tau yz. And sigma y value is again equal to 0. So we will not get sigma z. So from this condition you see the output or the interlaminar stress that we will get is only tau xz. So that will be the answer. Tau xz only. Interlaminar stresses at the interface of plus 45 and minus 45 degree lamina is developed due to the, so options are A, mismatch of Poisson ratio between plus 45 and minus 45 lamina. Option B, mismatch of coefficient of shear extension coupling between the plus 45 and minus 45 degree lamina. C, mismatch of Poisson ratio and coefficient of shear extension coupling between the plus 45 minus 45 lamina. And D, mismatch of shear modulus between plus 45 minus 45 lamina. So to create interlaminar stresses between plus and minus theta, any theta, here it is 45 degree. So you see the Poisson ratio of both this will be same. So first option will not be correct. Second is mismatch of coefficient of shear extension coupling between plus 45 and minus 45 degree lamina. So the second question that we discussed, it said that the shear extension coupling for plus 45 degree will be equal to minus of that of minus 45 degree. So these are non-equal. So that's why there is a mismatch of coefficient of shear extension coupling between these two lamina. So this is one of the correct option. C is mismatch of Poisson ratio and coefficient of shear extension coupling. Not true again because Poisson ratio is same for both of them. And mismatch of shear modulus between plus 45 and minus 45 lamina. So this is also not correct. So the correct option will be option B. It is that is there is a mismatch of coefficient of shear extension coupling between the plus 45 and minus 45 lamina. In an n-layered laminate where xy represent in plane and z represent thickness direction, the interlaminar stresses responsible for delamination are. So we already know like what are the out of plane and stresses. So because of which causes the delamination. So as the whole derivation is already taught in the class, that how from the force equation we can get the we already know the in plane stresses, and from using the force equation we will get the out of plane stresses that are tau xz, tau yz, and sigma z. And these out of plane stresses are the reasons because of which delamination happens. So the option for this question is that this all three of them are the cause for delamination, of which tau values are for shear because of shear stresses, and tau sigma is the normal stress. So plus 30 degree minus 30 degree symmetric graphite epoxy laminate when subjected to axial load Nx, which of the following interlaminar stresses develop at the free edge? So it is the same like the minus 45 plus 45 degree symmetric question we did. So here only the value of theta is changed, but the concept that for plus theta minus theta symmetric laminate, what we will get the output will be the same. So as I already discussed that for what will be the value we will get for plus 45 minus 45. Here again it is both plus and minus of some angle theta is given to us. So from that, the load Nx is given. We will get the ABBD matrix as there is no curvature. There is symmetric. That's why B matrix will be equal to 0. Only thing will be remain A. Load equal to the A matrix multiplied by the strain values. So now we from the given load and the A matrix, we will get the value of strain. From strain values, by using reduced stiffness matrix, we will get the values of stresses. So for plus minus theta symmetric laminate, we got that the stress values we get is that sigma x for plus and minus theta is equal, and both of these values are not equal to 0. The sigma y for plus and minus theta is equal to 0. Tau xy for plus theta is not equal to 0 but is positive, and tau xy minus theta is not equal to 0 and it is negative. So from this conclusion we see we don't get any sigma y, sorry, sigma y is not there, sigma x is there and tau xy value is there. By using that, the outer plane stresses we will get sigma y is 0, so this value will also you will not get, this value you will not get. The only value you will get is by using tau xy, we will get the value of tau xy. So option B is the correct one. The last question is that a 0 degree plus theta minus theta 90 degree symmetric graphite epoxy laminate, when subjected to axial load Nx, which of the following interlaminar stresses develop at the free edge at the interface of 0 plus theta symmetric? So as it has both the 090 and plus minus theta, so there will be the final values that you will get will be you will get the value of tau xy also. So tau xy value you will get because of the angles theta plus theta and minus theta, and sigma y value you will get because of 090. So according to that, you see all the values which are required to get the interlaminar stresses we will get. So those are all non-zero. So because of that, we will get all the interlaminar stresses, that is tau xz, tau yz and sigma z, they will be not equal to 0. So the answer, as it is a mixed laminate, so here you will get the value of all of them as non-zero. So option A is the answer. Yes, now who had some doubt, you can ask. I think Mohammad Alam, you were saying something.
Ma'am, second question and third question. Yes. Yes, ma'am. This eta plus 45 minus 45 is different, but for the Poisson's ratio, or same, how is this possible?
Yeah, so Poisson ratio, the definition of Poisson ratio is what? It is the transverse force divided by the longitudinal force.
Yes,
Correct.
ma'am.
So if you put the, imagine it like that. You have a laminate. It had the fibers aligned in 45 degree. Okay. So if you put transverse force on that and some, now the same thing, if it is minus 45, what will happen? Only the alignment will shift the to the other side. But still the values of longitudinal and transverse force that will be withstand by that will be same. So as so that's why the Poisson ratio will be same, because for either, even if it's a minus 45 or plus 45, the transverse load and the longitudinal load will remain same in both these laminas. So as those values will be same, their ratio will also be same. That's why Poisson ratio will also be same. But
But
that's
why, ma'am, eta is different?
huh?
But why, ma'am, eta is different?
Eta is different. Eta depends on for plus and minus 45. The shear coupling values will be like opposite to each other. So like plus 45 will move in the direction which will be opposite of minus 45. Okay, did you understand? So the it's like if you see the here the fibers are crisscross to each other. So when there is some force, shear force happening to it, the plus 45 will move such a way that minus 45 will be negative of that. Wait, I will. Can you see? So like it is like this. It is crisscross. See, it is plus 45. This is minus 45. If there is some stress, shear stress, so it will move like this. So because of the angles are equal to same, but the shear will be such that this plus. But for that, this minus 45 is opposite. Values are same. It is moving with the same amount of change in angle. The same amount will be there. But for plus 45, it is positive side, and for negative 45, it is in the opposite side. So that's why we are saying that the shear forces will be equal. Because the shear forces will be equal, but the value, that is, one of them will be positive, another one will be negative. Okay, so this is like a visual way. There is a mathematical way you can see by calculating also the shear stresses will be the same, but one is negative, one is positive. So it is because of that. That's why we are saying they are not equal, because of the sign. The movement of plus and minus will be opposite to each other with the same value. But because of their movement, they are going opposite. So there is a plus sign here and minus sign here. They are moving in the different direction. That's why they are not equal. Was that clear?
Okay, ma'am.
Okay. So in this question that you asked, 090 symmetric graphite epoxy laminate value of mu xy and mu xy 0 degree by mu xy 90 degree. So imagine it like this. Suppose for 0 degree lamina, the value of mu is transverse strength by longitudinal strength. Okay, transverse modulus by longitudinal. So anything transverse by longitudinal. So for 0 degree, suppose the value of transverse force is 10 and longitudinal is 5. The value of mu will be 2. Now, if you align the 0 degree one in terms of 90, so for 90, the value of transverse will be equal to the value of longitudinal for 0 degree. So that's why here for 90 degree it will become 5 by 10. So you see one value you are getting is 2, one value you are getting is 0.5. You will get the ratio. What will be the ratio? Okay, for 090, you see, I have here put an example also. So how you at the end you will find the value in transverse and longitudinal direction. So like this is one of the examples we have did in last classes with the same values. Like the Q matrix is given to us, we will get the A value, we will put load, and then we will get the strain values for 0 and 90 degree. And from those strain values, we will get the stress values in both longitudinal and transverse direction. So now you can see the value for 0 degree angle. It transverse will be 3.708 into 10 to the power 7 by 2 and so when you will get the ratio, you will get the value of the Poisson ratio. So 3.7 by 2, 2.2 and for 90 degree it will be 2.4 divided by 4.6. So that validates that for both 0 and 90 degree mu values will be very much different. Now the options that are given. So as I showed that the values will be different, so it will never be 1. 0, it can't be 0. There is always longitudinal and transverse stress. Minus 1 will also not be correct because the values are so different. So it will never be, ratio will never be equal to minus 1. So only option that is here is that Ex by Ey. So I think the value of the option D will be the correct one. That is Ex by Ey.
One for adjacent lamina, the interfacial says it comes delamination. Am I right,
What?
ma'am?
What? I didn't
The
get your
separation
question.
of the separation of adjacent lamina, the pile which caused by interlaminate says it is called delamination, ma'am.
Yeah,
The answer is delamination only, ma'am, right?
yeah. Okay, so Professor Kalpan Desai, you have also asked the same question about mu. So it will be Ex by Ey. It's the same question. Huh. So the same question asked by Anuj. So here the answer will be equal to Ex by Ey. That you can also like verify. See, Ex is stress by strain, and the strain values, stress by strain, and the Poisson ratio. From that, you can let it derive it also. I think it will be equal to Ex by Ey only, because all the other options 1, -1 and 0, the values for uh, stresses we get for 0 and 90 is very different. So they are not at all related to each other in any way, either they are negative or equal. So Ex by Ey will be the answer for this one. And for so for plus minus theta symmetric laminates, you see the mu values are equal. So if they are equal, their ratio will be equal to 1. So option A will be the correct one here. And also discussed in sample questions. Like here in plus 45 minus 45 graphite epoxy laminate, the mu xy plus 45 is equal to mu xy minus 45. So their ratio will be equal to 1. It is called delamination. That's what. So out of plane stresses are same as interlaminar stresses, and the out of plane stresses are this tau xz, tau yz, and sigma z, and these three are responsible for delamination. That's what Sir has taught. So these terms can be interchanged, out of plane stresses or interlaminar stresses, but they are always considering like talking about the same thing, that is this tau xz, tau yz, and sigma z, and they are responsible for delamination. So the conditions for either NX or NY will be same. So as I might have discussed in sample questions also, 090 NX. Yeah. So if they are talking about in normal stress, any normal force, either NX or NY, the conditions that you will get will be that, I mean, the normal forces for a 090 symmetric, the condition will be such that there won't be any shear stress. That is, tau xy will be equal to 0. So for tau xy equal to 0, you will not get the value of tau xz, but sigma y and sigma y value will be there when you will put a load of ny. Sigma z. So that will be like, if for a 090 symmetric, if the load is nx or ny, shear values will be equal to 0. Therefore, tau xy will always be 0. Only for 090. If there is 45 degree, if there is any angle theta, shear will be there. But for 090, there is no shear stress. That's why if the loads is nx or ny, shear because there won't be any shear, and that's why only sigma y will be there. So you will get tau yz and sigma z. Did I answer your question, Professor Kalpan Desai? Options. Uh, as I said, the sigma z and tau yz will be there, will be non-zero. So sigma yz. So option B will be the correct one. Right? Tau yz is equal to 0. No, sorry, tau xz is equal to 0. Tau XZ. Option A will be there. Option A, yeah. So any other doubts? Free edge delamination does not occur in symmetric laminates. In the laminate, out of plane interlaminar stresses are responsible for it. Second one is correct. The second one is true because delamination is caused because layered laminate. Okay, you can copy paste all the questions of the assignment here. It's like I'm not giving sample problems, I'm actually solving your assignment for you. Previous exam papers I don't have, sir, sorry. You can talk in the discussion or ask the course coordinators. They might be help. They might help, but I don't have access to any question papers. I'm only here to help with sample assignments. Okay, so tau x, tau yz they are asking about. So you see this thing. Tau yz they are asking. So for tau yz, what will be, you answer? What will be the value required to get tau yz? Hari, you answer this one. They're asking tau yz. Yeah, they're asking for getting tau yz value. Which value you need? So if you remember this one, you can see I explained. Can you see the screen? So the outer plane stresses that are, what are the outer plane stresses which are also known as interlaminar stresses? Those are tau xz, tau yz and sigma z. So getting those outer plane stresses, the values you require are tau xy, sigma y and only these two. Okay, and you can see all like sir has derived. What? So I'm saying that you see here for getting tau x, for getting tau yz, tau xz and tau z and sigma z, you need tau xy and sigma y. So from this thing only you can correlate, right? So what you asked? You asked that what in a layered laminate development of free edge interlaminar stress. Interlaminar stress same as outer plane stress. They're asking for tau yz, what value you will require. So you can correlate here for tau yz what value you require. This is tau yz. So for this tau
y, tau y.
You want this one, right?
This is the y.
Yeah, this is sigma y.
Sorry, sigma y.
Yeah, so that is how you have to correlate. What is the thing you need to understand? Interlaminar stresses are outer plane stresses, and that small formation that I showed, they have already derived it, and that is the final conclusion you have to always remember, and that is how you will get the condition for delamination. In a layered laminate, development of free.
I can understand the concept, ma'am, but in the option they are making some confusion, ma'am.
You didn't say what were the options. You just asked me the question. Anuj put the options. Then I understood what question you are asking. Professor Kalpan Desai, I think they won't be able to give you any previous year question paper. That's why they are not responding. So one of the sample questions that I discussed today is kind of related to it. This one. So here they are talking about plus theta minus theta, and the question that is given is about 090. So the same thing, how you will solve this for plus minus theta. You have to think about it and solve it for the plus 90, 090. Okay. So here you can see what are they talking about. Oh no. Yeah. So here they are talking about two things, Poisson ratio and the shear extension coupling. Now what is the conditions for Poisson ratio and shear extension coupling for 090? As we discussed in all many other questions before, that Poisson ratio for a 090, Poisson ratios are not equal to each other. So there is a mismatch between the Poisson ratio and the extension coupling, shear extension coupling values are equal to 0 and is equal to 0. So from these two conditions, you can answer this question, the question they have asked. They're saying mismatch of shear extension coupling coefficient of the adjacent plies, mismatch of Poisson ratio of adjacent plies, mismatch of both shear extension coupling and Poisson ratio, and none of the above. So what we concluded for 090, Poisson ratio is not equal to each other. So there is a mismatch of Poisson ratio of the adjacent plies. So option B is the correct one. Then comes mismatch of shear extension coupling of the adjacent plies. But for a 090, we have already concluded the shear extension coupling values are same and is equal to 0. So there is no mismatch. Option A will not be correct one. Option C, they are saying that both of them have mismatch. But we know shear extension coupling is equal to 0. So from that you can conclude what will be the answer here. All these questions are just based on like one simple concept, and they are all interrelated. Either the sample questions that I am teaching or the questions that are other questions in the like the assignment. So it's like one single concept and all the questions are related to it. So if you think and correlate, you can answer all of them. Okay. So who asked this? Hari asked. Okay, Hari, what will be the answer then?
From the mismatch of Poisson ratio and the adjacent pile.
Yeah.
Option B, ma'am.
Yes. Okay, so any other doubts? Ankit, do you have any doubts? Okay, then should I stop the session here? Or do you want to discuss any other? You don't have any doubts. Okay. Should I stop the session? Okay, then if you don't have any more doubts, then I will end it here. Okay, thank you.
Thank you.
This video will be available in YouTube, Kalpan sir. Yeah, video will be there in YouTube, but a little bit recording has stopped, so it will be little shorter one, but the PPT will be available in the folder, and also this video will be there in YouTube, and it is already shared, the problem solving link of the spreadsheet, I think, with you.
Ma'am, can you share the YouTube link?
You can, I think it is already shared. If you go to problem solving session, the spreadsheet, you will get both the PPT as well as the link to the video. Can you go and find right now? If you can't find it, then I will put a link here.
From the YouTube channel in name of Ananya Mandal, I can found and I have joined it.
What?
There is a YouTube channel in name of Ananya Mandal. I have found and joined it.
Hi, yes. There only I put all the sessions. Thank you, Anuj, for putting the link. Yeah, so I try my best. I will put these videos by the end of the night. So if you want to revisit and see the PPT and everything, I will put it in the drive. So you can check from there. Okay, Mohammad Alam, did you get the link? Anuj has shared here.
Yes, ma'am.
Okay. Thank you, Anuj.
I got it.
Okay, then I will end the session here. Okay.
Yes, ma'am.
Okay. So, good night.